Okay, good morning. This is Professor David J. De Los Reyes. Okay, it's October 15, 2023. The time is 6:04 a.m. Okay, my topic for this session will be a continuation of my long video format discussion. And my long video format discussion is AC machines, and this will now be lesson number 40. Okay, let's proceed. The subject matter for this morning will be AC machines, lesson number 40. We are now on lesson number 40 and we are running smooth. Okay? This will still be a continuation on the study of three-phase transformers. Uh, we are through with the study of the so-called, not true, we just finished delta and Y connection. And I have given you also problems on the Y and delta transformation or the reverse of it. So for this morning, we will be discussing the third variation and how we connect three-phase transformers. And the title of the subject matter is Transformer Open Delta Connection. Open Delta. Why open delta? If there is a delta to delta connection, okay, three-phase transformer, one phase, second phase, third phase, one phase, second phase, third phase. For this morning, we will be tackling or discussing if one of the transformers fail on the primary and one of the transformers fail on the secondary. Fail meaning they are faulty, they are not operating maybe at 100% or there is a problem with them, right? So if one of the transformers in the primary is missing and one of the transformers on the secondary is missing, we call those ones open delta connection. Okay? Open delta. This will be the windings. This will be the winding. This will be the winding. So if you try to notice it, okay, this should be line number 1, line number 2, line number 3. On the secondary side, this should be line number 1 also, line number 2, and line number 3. The problem here is the leg number 3 for both primary and secondary, it got no winding, right? So for it to become a three-phase, we just get this point here, we bring it out and we call that line number 3, and so with the primary side. So there is actually a problem with this one, right? There's actually a problem. That's why in the disadvantages, there is the so-called under the disadvantages number 2, the secondary voltage windings become unbalanced as the load is increased even when the load is balanced. With this type of connection, these voltages here, B and B here, will not be equal. They tend to become at a different value as the load is increased or even for a balanced three-phase load. So that's actually the what you call this disadvantage of an open delta connection. This is Islamic. I just give you a preview on what is delta connection. Okay, I will try to erase it. Okay, so at least we now know what is an open delta connection. So meaning open delta connection, if one of the legs of the three-phase transformer is defective, okay, and so with the secondary, so this is open, that's why the connection is open delta connection. Okay, you got it? It's not a complete thing because the third winding is missing, right? Why it's missing? They are defective, they remove it. Why they remove it? Okay, this should be single phase transformers which are interconnected to become three-phase. So if one of the transformers are actually defective for the primary and secondary, they try to remove it. So they will just reconnect the other two to form three lines, but the problem is on the third line, there was no winding, right? And so it is, there's no winding. So according to the disadvantages, okay, when the load is increased, or even when the load is balanced, this voltage B here will not be equal to this. It will not be equal. You see, there's no winding over here. Okay? So this will be the connection of an open delta connection, right? It should be line number 1, line number 2, line number 3. The third leg is missing, or the third single phase transformer is missing. So they just remove it. And the third single phase transformer in the secondary also, they just remove it, right? So what will happen? This should be the current per phase of the secondary, current per phase of the secondary side, primary side. Line current number 1, line current number 2. As you will see it, there is no current going here. So this might be, it seems the third line is actually a return path, right? Return path. You see? This will deliver current, this will deliver current, but this one here, it will not deliver. There's no winding over here. So it seems this is just a return path. So according to the disadvantages, as the load is increased for an open delta, this voltage here will be different from here. Okay? It is different. This one is bigger than this one. Right? So when the load is increased or even when the load is balanced, this voltage here is not equal to this. Okay? Okay, let's try to bring out the annotations. Annotations, it's just like an observation why we use open delta connection in real life. Because for a Y connection and delta connection, there will be no problem, right? There will be no problem. But for an open delta connection, there are annotations in which we must have to know it. Okay, annotation number 1. Before this annotation, it says here, open delta connection is employed or used when? Okay? This connection is used, okay, when? Okay? There's a when over here, right? Number 1. The three-phase load is small and no need for a three-phase transformer. Okay? So for an open delta connection, this is still very feasible to use. Okay? If the load is small. Okay? Small. That's fine. Right? This open delta connection, we could use it or we can use it if the load is small. Right? I don't know how big is that small, how small is that small. Right? Number 2, when one of the delta bank fails, of course, like what I said, when one of these fails, okay, we must have to revert to the open delta connection. That's the reason. That's annotation number 2. That's the reason why we use the open delta, because one of the transformers fail. Right? So if this fails, right, you must have to remove also the other one. So this is an open delta, it matches. Right? If this one fails and the other one does not fail over here, I don't think that we can operate this one with an open delta and this is a closed delta. It should be a open delta. Right? So annotation number 2, when one of the transformer fails, okay, you just remove also the other one, okay, for it to be an open delta. Number 3, Oh, this is just a storytelling. It is a so-called side order annotation, right? Service continue when the faulty is repaired and good one is substituted. Meaning to say, if the faulty one is repaired, okay, or a good one is substituted, we can continue service, of course, right? It is just a side annotation. It's just an additional concept. Okay, number 4. Open delta is used when the future load will increase to warrant the closing of the open delta at some later time. Okay? When the future load will increase, to warrant the closing of the open delta for a later time. Oh, this is just a side annotation. It is just predicting what will happen, okay, if the load will increase. Meaning to say, if we are having a small load here and we are using an open delta, right? And there come a time that the load will increase, okay? It's either that we will place a new one here or the repaired one, okay? So we could close the open delta for it to become a closed delta. That's the meaning of it. Storytelling. For the disadvantages, I will try to prove this one the next time around because this could be proven, disadvantages number 1. This could be proven by presenting an equation and we will be arriving at the value for 57.735. Disadvantages number 1, the total load of it can carry is not 2/3 of the capacity but only 57.735% of it. Meaning to say, if you got a 900 kVA, 900 kVA is very big. Because for open delta, it should be a small load, right? 200 kVA. So if the load here is 200 kVA, according to disadvantage number 1, instead of, because for a 3-phase delta, the load here is the same as the other 3 legs, okay? But we could not say that for open delta, this will carry 1/3 and this will carry 1/3. It is not. Because according to this, the so-called number 1 disadvantage, instead of 2/3 capacity, it become only 57.735%. Right? Assuming this is 300 for sake of simplicity. If it's a closed delta, one leg will carry 100, right? And at the other leg will carry 100. So 100 equals to 300, right? But for an open delta, the other leg is removed, right? It's not present. So for open delta, instead of delivering 200, which is 2/3 of 100, 300, right? 2/3. Okay, this will become 100. So instead of delivering 200, it will not be 200. It should only be almost 50%, 0.58, 0.5735 of 300. How much is that one? Times 3, 24, carry 2, 174. It will just only deliver 174 kVA. Okay? That is 58 or 0.57735%. So for an open delta, there is a discrepancy of around 26 kVA instead of delivering the full 2/3 200 kVA. That's the meaning of this. The next time around, I will bringing out the formula how come it is only 57.735%. Okay? So this could be proven by presenting an equation over here, and it will come out that the total capacity that could be delivered by an open delta is only 57.735% of the given load. Okay? Oh, that's disadvantage number one. Instead of delivering two-thirds, it's not two-thirds, it's only almost 50% of the given rated capacity. Right? And disadvantage number two, the secondary voltage tends to become unbalanced as the load is increased or even when the load is unbalanced. When the load is balanced. Meaning to say, since there is no winding on the third line, of course the voltage here is different from the voltage here. So if they are different, they are unbalanced. Right? Yeah, because this voltage here should be the vectorial sum of the voltage across this plus this. But the voltage here, it will be this voltage here, okay, and there's no voltage on the third leg, right? Because there's no winding, it's an open delta, right? So of course, this voltage here is less than this. That's why they say it's unbalanced, right? If the voltage here is different from here, there's a problem. Why there's a problem? There will be a circulating current, right? Circulating current. This is a greater voltage than this. There should be circulating current. We pass by the computation of the circulating current, right? So there will be a problem with circulating current if this voltage here is bigger than this, and we cannot do anything about it because for an open delta, this voltage here is bigger than this one. This voltage is the vectorial sum of these two voltages here, and this voltage here is the vectorial sum of this voltage plus 0, right? There is no winding over here. Okay, that's it, guys. That's the so-called storytelling portion of the so-called open delta connection. Storytelling, it's the concept, but it's the foundation of the knowledge on how to study open delta connection. The next time around, I will be discussing the formula or the so-called derivation on how to bring out how come the capacity rating that could be delivered by an open delta is only 50% of its rated capacity. Okay, good morning from Los Angeles, Professor David Gilles.